Alright, in this video, we're going to be going over investigation 9.2.1. So, the focus for this question is how can we interpret graphs of linear inequalities? So before we talk about linear inequalities, let's just do a quick review of linear equations. So here I have a linear equation. We know this because it's in the form y equals slope x plus y-intercept. So here, given these numbers, how can I graph my line? So notice the plus 3 right here, that's my starting point. So I'm going to move my green starting point to 3. And my slope is negative 2, which means from my starting point, I'm going to go 2 spots down and then 1 spot over, right? There's like an invisible 1 down here. Negative 2 over 1 is negative 2. So this is how I graph this line. So is negative 1, 5 a solution to the equation? Well, to plot negative 1, 5, notice I need to move left 1, right? My x value is negative 1, and up 5. And how can I tell if negative 1, 5 is a solution? I can tell it's a solution because notice how it lies on top of the line. Since the point is on the line, I know it's going to be one of the answers. And the other way I can tell is by plugging in the number. If I plug in negative 1 for x, I can see if it matches up with y. So let me copy and paste, Control C, Control V. And now I'm going to plug in negative 1. Okay, plug in negative 1. Negative 2 times negative 1 is positive 2 plus 3. And 2 plus 3 is 5. Notice that when I plug in negative 1, I got the same answer as y. So both sides of the equal sign ended up being the same. All right, let's see if another point lies true. Here, let's see if 2, negative 1 is a solution. So to get to 2, negative 1, I need to move 2 to the right and down 1. And I notice that this point also lies on the line. So it's probably going to be a solution. So let's test it out by plugging in our number. Let's plug in x. Again, x is the front number, 2. So let's copy and paste. Since x equals 2, let's plug in 2. Negative 2 times 2 is negative 4 plus 3. And negative 4 plus 3 is negative 1. Right? And that's the same answer we got for y. So notice that if I plugged in if I plugged in 2 and negative 1, notice how it solves the equation. Right? Third example, is 0, 0 a solution? Well, the first thing I noticed that it's not on the line, right? 0, 0 is right here, the line's over here. So the point's not on the line. But let's try plugging in the number. Let's plug in x equals 0. So I'm going to copy and paste. And when I see x, I'm going to replace it with 0. See, 0 times anything is still 0. And 0 plus 3 is 3. Right? And notice that these are not equal. 0 does not equal 3. And that makes sense, right? This point isn't on the line. So those numbers 0, 0 wouldn't be solutions to the answer. So how it determines if a point lies on the line? And what's the difference between points that are on the line and not on the line? Right? Points that lie on a line have to be solutions to that equation. If the point is not on the line, it is not a solution. Okay. So next section. So far we talked about linear equations with an equal sign, but what if we want to talk about inequalities with this less than or greater than sign, the little arrow symbol? So what would be the difference between these two equations? They both have negative 2x, they both have 3, but if I change this equal sign to an inequality sign, what would be the difference between the graph? So here, what do you think is going to be a prediction? What do you think is going to change? Right? I think both will be similar. Right? So whatever you think how the graphs are going to change, go and put your predictions here. Again, no right or wrong answers. Just guess what you think is going to happen. And we're going to double check our answers over the next couple pages. Okay? So after you wrote your prediction, let's move over here. All right. So notice when I remove this dot, my x and y values are going to change. For example, if I'm over here, x is negative 1, y is 1. Over here, right 4 up 3, x is 4, y is 3. So depending on where I move my point, I'm going to have different x and different y values. And if I plug in these x and y values, for example, if I plug in negative 1, 1, plug in negative 1, 1. So if I times it and plus it by 3, notice how this table solves my equation, right? Here's the answer to the inequality. So what I want to do on this slide is, can you try different points and see if they make a true statement down here? So for example, negative 1, 1. 1's definitely not bigger than 5. 5 is supposed to be bigger. So this is a false statement. So I'm going to click false right here. Notice how when I click false, it left behind an x at that spot. Right, if I try another point, let's see this point right here. Let's try 1, 1. If I plug in x equals 1, y equals 1, Let's see, negative 2 times 1 is negative 2, plus 3 is 1. And 1 is definitely greater than or equal to 1, right? These are equal. So this is a true statement. I'm going to click true here. And if you kept trying different points, right? Let's try a number over here. Let's try 4, 3. So if I plug in 4, plug in 3, let's see, those cancel out. Negative 8 plus 3 is negative 5. And 3 is definitely bigger than negative 5. That's a true statement. So if I kept trying numbers, let's see, that's false. This is true. Down here is true. So if we keep trying numbers from the left and the right side, hopefully you can start seeing a pattern of where true answers lie and where false answers lie. So where do we see false answers in our inequality? And where do we see true answers in our inequality? So after doing this a couple times, notice that true answers are only located on the right-hand side over here. So how many solutions are there? Again, we've been checking only points, but again, these decimals, these numbers in between could also be answers. So basically anything in this region over here, we have infinite number of solutions. And what do these points represent? Right? Where are these points located? The points that are solutions have to be above the line. Right? Notice that the inequality is greater than, any value that's greater than y, that's on top of the y value, is going to be an answer, right? If I plug in this number or any number over here in this region, it's going to give me a true inequality, right? Something that's true. What happens if I flip the sign? So instead of facing to the right, now it's facing, or facing to the left, it's now facing to the right. So notice how when I flip the sign, all the correct answers are now down here, right? 2 is smaller than 9, that's the correct answer. That's a true inequality. Negative 3 is less than 5, that's true. And anything over here is now wrong. 2 is not bigger than negative 3. 0 is not bigger than negative 7. So things that are correct are now over here, and things that are incorrect are over here. So the new way I would shade this would be anything to the left now is going to be a true statement. Notice that when I flip the sign, the way I shade, where I shade is going to be the opposite. Right? Everything to the left here is going to be true. So let's go and just practice some graphing. So the first part is just to use y equals mx plus b and make a graph. And then we need to think about, is it going to be shaded above, below? Is it a solid line or a dotted line? So here at negative 1, here's my starting point. And my slope is rise, run 3. So from the starting point, I count up 1 and to the side 3. From here, since it's not equal to, it don't have that little dash down here, it's just an inequality, it's going to be a solid line. And since y is greater than, do you see how the alligator mouth is going to face towards y? Since y is greater, I'm going to shade above. Okay. Oops. Y is greater than. Negative 1 up 1 up 3. Oh, sorry. My mistake. Since this is not a solid line, this is going to be a dotted line, sorry. So since there's not equal, right? We're not going to include this line. We're going to make it a dotted line. Sorry about that. Okay. So over here, let's try this again. We're starting at plus 2. And here our slope is 4. So from my starting point, I'm going to count up 4. 1, 2, 3, 4 to the side 1. So here's my graph. Since I'm including the line, do you see that little dash here, that equal sign? It's going to be a solid line. This is going to be a solid line. And since x is smaller than, do you see how the alligator mouth is eating the other side? Since y is smaller than, it's going to shade below. All the y values that are below that line are going to be true. Over here, let's graph this one. We're starting at plus 3. All right, and then here we're going down 5 over 2. Down 2, 3, 4, 5 over 2. Okay, so again, since we're not including the line, it's going to be a dotted line. And notice that since it's smaller than, right, the alligator mouth is facing the other way, it's going to be shaded below. And for the last one, let's see, starting at negative 5, let's move this to negative 5. Slope is positive 2, so up 2 over 1. And notice that y is greater than, right? The alligator mouth is facing towards y. So again, this is a solid line that's shaded above. So how can we interpret graphs of linear inequalities, right? The line will be the same as a linear equation, right? If it's equal to, it will have a solid line. If it's not strict, it will have a dashed line. If it's greater than, we will shade above. If it's less than, we will shade below. So those are some ways we can interpret linear equations. So let's do some practice problems. Here we have 4 graphs. I'm just going to order them. Here's 1, 2, 3, 4. Oops, don't want to connect that yet. Okay. And here we have our 4 options. So here, notice for this first graph, we have a dotted line. So we want one of the ones without the equal sign, right? And we know that it's going to be shaded below. So y is going to be smaller, right? Shaded below. So the other dotted line, right? Notice how it's shaded above. So this one is, again, a dotted line, not strict inequality. That's shaded above. Let's see, here we have a solid line, so we did equal. This one is shaded below, so we need something that's shaded below. And the whatever's remaining has to be the correct one. Okay, so here are the 4 possible answers. All right, here we have some equations we can solve. So let's see, plus 2 to both sides. 3x has to be less than 12. Then we can divide both sides by 3. Oops. 3x is less than 4. So here's my 4. And x is anything that's less than 4. All right, any number I use here has to be smaller than 4. Notice that we didn't flip the sign again. We kept everything positive, so there's no point in flipping the sign the other way. Okay, over here, let's see, 5x minus 3x, that's going to be 2x minus 1. All right, keep that same symbol for now. And then 4x plus 5. Okay, now let's go ahead and cancel out these 2x's. Again, I find it easier to get rid of the smaller x. So minus 2x on both sides. Notice that plus 2x minus 2x cancels out, leaving me with negative 1. This is greater than or equal to 2x plus 5. Let's get rid of these plus 5 by minusing 5 on both sides. Again, plus 5 minus 5 cancels out. 1 negative and 5 more negatives. Again, 1 negative and 5 more negatives. 2, 3, 4, 5, 6. Those have 6 negatives. Negative 1 and 5 negatives make 6 negatives. Negative 6. And if I divide both sides by 2, negative 3 is greater than or equal to x. So here is negative 3. Again, I'm including negative 3 in my answer. And negative 3 has to be the bigger number, right? X has to be smaller. So my arrow is forcing this way. All right. All my x values are smaller. Notice that the alligator mouth wants to eat negative 3 because negative 3 is the bigger number, right? Everything else has to be smaller. All right, 2 more. Let's see. Let's do distributive property. 2 times x is 2x. 2 times 2 is 4. Greater than 10 minus x. Just like before, we have x on both sides. So let's cancel out these x by adding x to both sides. So I'm left with 3x plus 4 is greater than 10. All right, cancel out the 4 by subtracting 4 on both sides. So 3x equals 6. And if I divide by 3, divide, x is going to be 2. Oops, sorry, did I do that correctly? Minus 4. Oops, sorry, I used equals. I'm supposed to use the inequality sign. Sorry. Halfway there, I switched signs. Yeah, sorry, I'm supposed to keep the same sign. So from there, let's see. X is bigger than 2, so here's 2. Right, and since x is bigger, right, the alligator mouth is facing towards x. On anything that's bigger, right, x, any of these possible x values has to be bigger than the 2. And the last one, this is a review from the last lesson, a absolute value. So again, I have 2 possible answers. This can either be the positive version, where we're coming in from the right side, and this could be the negative version, where we're coming in from the left side. So here, let's go ahead and solve for x. Cancel out the minus 4 by plusing 4 on both sides. If I divide by 8, x equals 2. Here, plus 4, negative 12 and positive 4, those cancel out to get negative 8. And divide, x equals negative 1. Okay, so that's investigation 9.2.1. And if you still have questions, please let me know.